Alright, you guys, we're going to try something a little bit different. Usually when I do a video like this, it's just a watch and do. I'm actually going to try and lead this a little bit just because it's new material and do my best to try and minimize me being out. And we'll see how it goes. I guess what I need you to do hopefully somewhere close to you, we've got scissors. You'll need a compass. And you can share a compass. All you're going to need is to make one circle, and then some string. And I've cut some string, and there should be something here to pass out to get you some of those. So close by, you need some scissors, a compass, and a little piece of string. We're going to do a little investigation here, and if you go to Activity 1 of GCB 5, so find that. It's a couple sheets down. GCB 5. GCB 5. It's hard to read. Activity 1. That's better. GCB 5. GCB 5 Activity 1. It says Activity Discovering Radians. That should be in your notebook a couple sheets down. You are going to skip a few pages to find it. And the activity is fairly self-explanatory, so not a great amount of work at this end to get it going. But let me just walk you through what I want you to do, and then I'm going to let you do it, and then I will kind of debrief it with you. So the way it works is, if you're reading there with me, how it goes, it says, use a compass to construct a circle of any size. So in a minute, you'll take your compass, make any circle of any size on your piece of paper. Mark your center. That's a very important thing. So when you make your circle, make sure you have your center marked. And then you're going to take, and it says here dental floss, pipe cleaner, whatever, you're going to take your little piece of string, you're going to stretch it out and cut it so that it makes exactly one radius. And you want that radius string, you're going to need to use that to help measure. And then it says pick any point on the circle. So let's say this is my circle here. I think it said place point A on the circle somewhere. And then what I want you to do is to start to lay down your string along that edge until it stops, and then make a mark, and then lay down the next one until you make a mark. And you're going to wrap your circle with as many radii as you can without overlapping. So you're going to go around all the way there, and then it says, so from point A, use your radius to determine how many radii fit along the edge of your circle. With each radii, place a point on the circle, and that'll help keep track of them. So this was one radius, this is the second radius, and so on. Move your way around the circle. When you're done that, take a minute to follow the six little items here. It says how many approximately did you get, compare it to other students, what do you notice about these values, and so on. So I want you to just take a few minutes now to do that work, and then we'll come back to the video for a little debriefing at that stage. So pause this now and go do that activity, and then when you're done, we'll start it up again. All right? Go get at it. All right, let's debrief. Now normally, of course, this would be question answer, but I'm just going to kind of hopefully connect the dots for what you found. And if you didn't find this, then write it down as I discuss it. So estimating how many radii go around the circle, I'm sure all of you picked a number close to 6. Some of you might have thought rounding it to 6. Maybe some said 6.1, 6.3, something like that. But I think in 1 and then in 2, when you compared it to other students, I'm sure if they did it correctly, everybody would have found values around 6.2, something like that. Now I guess the question is, well, it says, what do you notice about these values? And the answer, of course, is that they were all basically the same. And so the question is, why should they all be basically the same? We actually already discovered this slightly in an earlier class where we talked about how circles are all similar to each other. So a very small circle has a proportionally small radius to a very large circle that has a very large radius, and that the relationship of those two items stays proportional because all circles are similar. Now, because they're all similar, we all got a value between 6.1 and 6.4. And why are we getting all different values is just because of how imprecise our measuring is. We're using string and those types of things. But the question that's more important is, why did we all get about 6.2, something like that? And the answer has to do with a formula that we know called circumference. Circumference is 2 pi r. Now, circumference is walking around the edge of the circle. That's what you did with your radius. And this tells you how many radii fit along the edge of your circle. 2 pi of them fit along your circle. Now, I don't like to estimate pi, but let's do 3.14. And if you doubled 3.14 by multiplying it by 2, you get about 6.28 radiuses around your circle. That's why we all got 6 and a little bit. That's the little bit right here. And so we leave 6.28 behind, and we say that a circle has exactly 2 pi radiuses upon it. Now this leads us, well, let me just see if there's another question. Oh, how many fit around it using circumference? So this is the final answer. Exactly 2 pi radians fit around it. So why did we have to rediscover something we kind of already knew? Well, the answer is this is a very important piece to introducing a brand new way of learning about how to measure an angle. So you and I have always done degrees, and if our calculator was ever set in something called radians, we would say, quick, go to the mode, get out of it. Well, we're about to introduce to you what a radian is. So let me set that up for you to discuss it a little bit. All right, let me introduce what 1 radian is. So first of all, again, it's a measurement of an angle size. You are very familiar with degrees. We've just spent many days working with degrees and finding arc degrees and angle degrees and those kinds of things. Well, part of this unit, the last piece of the unit, is to introduce to you something called a radian measure of an angle. Now, it's a fairly technical item here, but let me walk you through what it is. 1 radian of angle measurement is this size right here. And it's an angle size that's formed by making the central angle on an arc of 1 radius. Now the power of that is that whether your circle is small or big, this will never change. The size of that angle for 1 radian of a little one or of a big one is consistent, is locked in. And the reason for that is because if we did a smaller circle with a smaller radius, let's say this one, its radius has decreased, and so its radius would fit right in there, and it would still be exactly 1 radian. So 1 radian of measure, the central angle that intercepts, so the central angle that intercepts an arc of exactly 1 radius. And that is uniform for all circles, because if you had smaller circles, you have smaller proportional arcs. They all stay proportional. So what I'm going to do is I'm going to walk you through the next worksheet, which is activity 2. I'm going to walk you through some of the understanding of what a radian is to get a little sense of the measurement of it and how it works so that you can work with it a little bit. So the big idea is a radian. Now when you look at this, think about what 1 degree looks like. A 1 degree is like a tiny, tiny sliver of an angle. 1 radian looks to be about 60 degrees. It's not exactly 60 degrees, but it's kind of around there. The reason it's not 60 degrees is because then 6 radiuses would fit around a circle, and we know 6 doesn't, 2 pi radians fit around it. So, but we sometimes use 60 degrees as a way for students to make sense how big a radian is. 1 radian is, at least for now, around 60 degrees. I think it's closer to 57 or so, but we'll go from there. Let's pull out your sheet, and I'm going to go under the Elmo to walk you through some things, okay? All right, so you've grabbed activity 2 here, and this is going to I'm just going to walk you through getting used to what radians are as kind of an introductory to it. I will kind of skip around a little bit, and again, it's hard for me to judge how long time will take or how much time you've already taken in class for the activity. But let me just walk you through kind of some of the essential things. First of all, as it says at the top, radians are an alternate way of measuring angles. And as I tried to mention on the board earlier, an angle with its vertex at the center of a circle that intercepts an arc of 1 radius is called 1 radian. Makes sense that it's called a radian if it's made up of radii. So the angle above is exactly 1 radian because it has 1 radius. And so what this next thing wants us to do is to maybe get a little sense of size. So it says, how many radians do you think you have there? And that looks like about 2, right? Because 1 radius puts us somewhere over here. It's probably about 2 there. How about this next one? That looks like about 4. There's probably 1 to about there, 2 to about there, 3 to about there. One thing maybe to help you to understand why it's not exactly 3 there, because if it's 2 pi radiuses around a circle, then halfway around the circle would be pi radiuses or pi radians. And so that would be like 3.14 of them. So that's why I know that 3 doesn't go right there. So anyways, that's about a 4. This looks like about 6, doesn't it? Because there's a 6 in a little bit. And then that's our 3. Do you see how 3 is not, straight across a diameter type of thing? I'll let you come back and fill in what you think approximately those degrees are. Again, this is just guessing and approximating. So how many radii fit around a circle? We know that exactly 2 pi of them. That's going to be a very important number. And, well, it's a big converter here. So this idea of 360 degrees is once around a circle. Well, 2 pi is also once around a circle in radians. And so this becomes a conversion tool for you. And I actually don't use this one. I use a different one, but it's based off of this one. So this idea that 360 degrees is exactly 2 pi radians. So if 360 is 2 pi, how much is 180? It's exactly pi radians. So I discussed that already. This would be an angle measurement of pi radians. Now immediately you can see one of the issues with radians is that how many you have is going to be a funny number because it's going to involve pi usually. Not always. You can talk about 2 radians or 10 radians, but usually it's involving pi. Here, for instance, 90 degrees. Well, if the full circle is 2 pi, that's 360. Half would be pi, that's 180. And half of that would be pi over 2. Pi over 2 radians is 90 degrees. So if this is a half, a half of pi, 1 pi, 1.5 pi. So this is the way you write 1.5 pi is 3 pi over 2. Let's look at this. 120 degrees. How much is that in radians? Well, think about it this way.
120, if you divide 120 into 360, you get 3. So dividing by 3 would give us 120. So if we divide this by 3, we would get our value for 120. So again, this whole context of a conversion tool here of 360 and 2 pi allows you to obtain quite easily the values of how many radians. And again, let me just explain that idea. That angle size there, again, there are 3 of those, right? So the whole thing is 2 pi, and I'm dividing it by 3. That's one way to kind of think about its value. Let's keep going here. Let's look at the next one. So again, I'll leave some of these things for you to do. Let me kind of set them up in the patterns a little bit. One of the cool things is that you can get a bunch of answers by knowing one answer. Let me explain what I mean here. 60 degrees is exactly 1/6 of 360. So that means that 60 degrees in radians would be exactly 1/6 of 2 pi, which is written, when it simplifies, as pi over 3. Now what's cool is if pi over 3 is what 60 degrees is, then 120 would be 2 pi over 3. And what would be 180? That would be 3 pi over 3, which is just pi. And another group of that would be 4 pi over 3. And another group of that would be 5 pi over 3. That would be, again, exactly 300. And of course, 6 pi over 3 is just 2 pi. So what I'm showing you, even though it's fractions, and that's a scary thing, is that the idea that 1/6 of a circle is 60 degrees. So 1/6 of 2 pi would also be basically like 60 degrees. And so if you double that to get 120, you double pi over 3, or triple it, or multiply it by 4, or multiply it by 5, or multiply it by 6. So I'll let you do these two charts to show you kind of the same pattern, but here's the idea. If pi over 4 is the same as 45, then 2 times pi over 4 would give you 90. And this simplifies to pi over 2. Or 3 times pi over 4 would give you 3 groups of 45, which is 3 pi over 4. So you can keep doing the increments to get each of the values along the way. So like I was doing above, 30 degrees is 360 divided by 6. 360, or no, think about it this way. 360 divided by 30 is a total of 12 of them. Yeah, I stopped there for a minute. And so when you take 2 pi and divide it by 12, we get pi over 6. So pi over 6 is exactly the same size as 30 degrees. So 60 degrees would be 2 times that. So 2 times pi over 6 simplifies to pi over 3. There's 60 degrees. Again, in radian measure though. 90 would be 3 groups of pi over 6, which is pi over 2. That's exactly 90 degrees. So off you go. You can complete these and fill them in. The last thing I'll have you do, we won't do any homework assignment other than complete the things that I've skipped here, and I'll leave you a few things to do, is to convert each of these degrees into radians. And that should prep us for tomorrow's experience to get a sense of it. Let me walk you through a few of the easy ones. So here's 0, but it's also 2 pi radians because 360 is 2 pi. So if you go half of the way, we've learned that this is pi over 2. Okay, so that's pretty easy. If you go half of that distance, half of 180 is 90, which would be pi over 2 here. Now, what I like to do is I like to find these guys out. Again, remember how 30 degrees, it's on the other sheet. You can get some of these on the other sheet, but 30 degrees is 2 pi divided by 12, which is pi over 6. Now, if you have that one, you can start getting other ones, like doubling that one gives you 60 degrees, which is 2 pi over 6, which is pi over 3. And if you double that one, you can get the next one, and so on. Always reduce your your fractions to the most simplest form. I'll go over this at the introduction of the next class and make sure you've got the right things and kind of re-explain it to you. But what I'd like you to do is just finish up any of the loose items that I've left behind here, and that will be our assignment for today. Thanks, guys.